So here we have three scatter plots. Now we're not talking about residuals, we're not talking about the line of best fit, we're just looking at what the data actually shows. So here we see data that's a perfectly straight line. Here we see data that kind of looks like a straight line, and it's negative. And here we see random data. It's just scattered all over the place. There's no real trend. So part of what we also need to know is how to describe how tight of a line it is. So we need to see the strength of the relation of the plots to each other, and how close they are to a line and how close they are not to a line. This is known as correlation. And the way you find this is by finding the correlation coefficient, which you're going to find on the same spot on your linear regression equation on your calculators, except you're going to need to turn catalog on because the way it's going to show you it is R. Something that has a perfectly straight line like this is going to have a correlation of 1. Okay, it's perfect. If it has a negative slope and it's a perfectly straight line, it's going to be R equals -1. It's perfectly straight, but it's a negative slope. Here, if the data has no correlation and it's completely random and there's no linear anything, R is going to equal 0. So basically our range for our correlation coefficient is -1 and 1. Okay? The closer you get to -1, the more compact and straight the lines are going to be in your scatter plot with a negative slope. The closer you get to 1, you're going to have a positive slope, and the tighter and more straight and on the line they're going to be on your scatter plot. The closer it is to 0, the more random it's going to be, negative or positive. Now, if it's not perfectly straight, but it's not completely random either, it's going to be somewhere in between 0 and -1 or 0 and 1. So since I can tell this is negative, I know it's going to be between 0 and -1. So it's a pretty good line. It's not that random. So I'm going to say it's -0.70, that R equals -0.75 as my correlation coefficient. And that's decently accurate. But on a Regents problem, it's not going to have you guess the correlation coefficient. It's either going to ask you the correlation coefficient in two different ways. The first way it's going to ask you is, it's going to give you a multiple choice question. It's going to show you one like this, and it's going to say, is the correlation coefficient 0, 1, 0.5, or -0.75? So you can immediately take off at 0 because it's not random. You can immediately take off 1 and 0.5 because it's a negative curve, so the only answer left is this. The other way it's going to ask you, like on a free response question, is the exact correlation coefficient for what R equals. Now, I made a video about how to use statistics on a calculator, how to find your linear regression and things like that. So on the TI-84 and the TI-Nspire, you're going to do the exact same thing. You're going to plot all your dots on your scatter plot, and what you're in your L1 and your L2. And basically what you're going to do is you're going to turn the catalog feature on the TI-84. What you're going to do is you're going to go right back to the linear regressions part of your statistics button. And what it's going to show is it's going to show you R. And that's literally all you have to do. So you just have to turn the catalog on. The correlation coefficient is very simple. Just to review, the closer it is to a straight line, the closer it's going to be to 1 or -1 if it's a negative slope. The more random it is, the correlation coefficient is going to be 0. Hey, thanks for watching this Crash Course video. To watch the previous video in this series, click here. To watch the next video in this series, click there. If you want to request a video, make sure you put it in the comments below. And don't forget to subscribe and like this video.